Hello everyone, welcome to LX518. Today my topic is about laser detector card repair. What you can learn from this video: first, how to find a substitute for a relay by identifying its electrical specs and internal circuit. Secondly, a simple method for verifying a faulty relay using electrical tests. Please watch the video until the end to see how important the freewheel diode is in a relay coil. Also, feel free to leave comments if you need any further clarifications or have suggestions for improving the content of this video. Really appreciate your support. Thank you so much. Alright, I'm going to share you a little background with this topic. We have the internal customer reported a faulty laser detector card, stating that their equipment can no longer detect the laser signals and strongly suspects that the card is the cause of the issue. Purchasing a new card would cost around 3,000 USD with a lead time of 2 weeks once payment approval is completed. The customer also mentioned that this equipment is a critical tool and they need to restore it as soon as possible due to the increase in backlogs. Immediately I performed a component level troubleshooting, and luckily I found right away the root cause is the faulty relay. The relay in question has a rated coil voltage of 12 volts DC and a line current capacity of 0.25 ampere. Referring to figure 2.3, I verified the faulty relay by isolating and energizing the coil according to the specifications. And based on the internal circuit of the relay in figure 2.2, when energizing the coil, pins 8 and 14 should make a contact. However, they did not. So it's clearly understood, or it clearly indicates that the relay is stuck even though the coil is energized. By the way, relay coil voltage refers to the voltage required to energize the coil of a relay, causing it to operate. And the relay line capacity refers to the maximum electrical current rating that the relay's contact can safely handle. Thank you. The fastest solution we came up with at that moment to repair the laser detector card was to find a relay from our spare parts that could substitute the original one. Figure 3.1 shows the original relay, including its markings, internal circuit, coil voltage, and line current specifications. Identifying these details was crucial for selecting a suitable replacement. Fortunately, as shown in figure 3.2, I found the best candidate from our spare parts to replace the original relay. It has a 12 volts DC coil voltage rating and a line current of 6 amperes. Although this is significantly higher, it should work without any issues, so I wasn't concerned. However, since the internal circuit was different, I made a quick modification by adding jumpers to match the switching function of the original relay, as shown in figure 3.3. Additionally, I noticed that the original relay had a built-in diode which we couldn't overlook. This diode serves as a protection for other components against voltage spikes or reverse current generated when the coil is de-energized. To replicate the original relay's functionality, I added an external diode as shown in figure 3.4. After completing all modifications, the equipment engineer reinstalled the laser detector card. The equipment was successfully restored then and running on the same day. Thanks to the quick modification, we managed to save the day. Great job! Further illustration of why a relay freewheel diode is important. When the circuit is turned on, current flows through the coil, but the diode does not conduct because it is in reverse bias. When the circuit is turned off, the coil attempts to sustain the current flow. Since there is no path for the current to flow, a diode is connected in parallel with the coil. This allows the current to circulate through the diode, preventing voltage spikes from harming other components in the circuit. Thank you. Further illustration in figure 5.1. When the circuit is turned on, let's say there's no diode across the relay coil, the current flows through the coil, storing magnetic field energy. When the circuit is switched off, as shown in figure 5.2, there is a chance that the stored energy could discharge through the transistor and potentially damaging it. In contrast, referring to figure 5.3, if a diode is placed across the relay coil, then when the circuit is switched off, the energy will just circulate through the diode and quickly dissipate until it is gone. Therefore, it protects other components in the circuit. Thank you. Thanks for watching. I hope the video is helpful for you. I wish that I could do better next time. Anyway, I'm happy you have been here. Hasta!